Alright, so this is question of the day on day 4. Given two terms of a geometric sequence, find the first, third, and fourth terms. And already I can see from this that, so we have 202 and then we have 25.25. So basically it's a geometric, it's a geometric decrease because obviously 25.25 is less than 202. It's a geometric decrease, and you can see, if you notice, 25.25 is 8 times less than 202. And since these are three terms apart, then basically you can see that that means that the third term has to be 2 times less than the second term, the fourth term has to be 4 times less, and the fifth term is going to be 8 times less. So basically our common ratio is that everything is going to be halved each time. So our common ratio would be 1/2. And then in order to find the first term, we would have to multiply it by 2 because we're going backwards. So that would be 404. And then 202 divided by 2 is 101. And that divided by 2 is going to be 50.5. 50.5. So for the nth term, I'm not entirely sure what that means, but the nth term, I'm going to assume it's talking about like what it eventually like approaches, if you I guess, and it basically approaches 0 because if you keep dividing by a number by 0, not by 0, by 2 over and over and over and over and over, it's eventually going to get infinitely close to 0 without actually touching it. So basically it approaches 0. Our 10th term, then that would just end up being our first term, which is 404, times 1/2 to the 9th power, because since it's the 10th term that we're talking about, and since we already have the first term right here, we would have to do it times to the 9th power. So I'm just going to calculate it using my calculator. So 1/2 to the 9th power is 1 over 512. And 404 times 1 over 512 is equal to 101 over 128, or roughly 0.789. For the 46th term, we have to do the same thing. We have to do 1/2 to the 45th power, and then we have to take that and multiply times 404. And that gives us, in our calculator, I got roughly 1.148 times 10 to the negative 11th power, because it's given in scientific notation, because this number is so small. So given the sequence above, determine the partial sum from term 4 through term 10. So obviously our method for finding the sum of a sequence is going to be the initial value, which is a, times 1 minus the common ratio to the whatever power, so the number of terms to the nth power, all over 1 minus the common ratio. So obviously we can see it's asking for term 4 through term 10. So that means this is our fourth term right here, 50.5. So this is going to be our initial term. And when you're talking about terms 4 through 10, we're going to be talking about 7 terms. We have 4, 5, 6, 7, 8, 9, and 10. So those are 7 terms. So, and then our common ratio, like we've already established it up here, it is 1/2. 1/2. So that means that we're going to have 1 minus 1/2 to the 7th power all over 1 minus 1/2. So the bottom will just simplify to 0.5. So now we can just put this in our calculator. So 50.5 times 1 minus 1/2 to the 7th power all over 0.5. That gives us a sum of 100.21, rounded to the nearest 100th. Nearest hundredth. We get 100.21. So the infinite sum here, basically what we have to be looking at is our first term is 404, our second term is 202, so that gives us 606. Our third term is 101, which gives us 707. And if you keep adding stuff, you notice that we slowly but sure, we slowly approach 808 because our common ratio is 1/2. So that means that we approach 808 because it's 404 times 2. So our infinite sum is going to be 808. It never actually reaches 808, but it gets infinitely close. I guess that could be whatever the equivalent for asymptote is in a series or a sequence. That I guess you could say that that's the asymptote. And the sequence does have an infinite sum because we are decreasing. Because we are decreasing. So it's not actually, because if we were increasing, then we wouldn't be able to determine anything because our values would basically just end up reaching infinity. But since we start at a fixed value, which is 404, and then we just go lower and lower and lower. We just go lower and lower and lower, eventually approaching 0. So that means that we are going to have a cap at where we are going to have a cap at the sum of this. It's not going to go to infinity or anything. And yeah, it's because we're decreasing, so we're never going to be having infinitely increasing numbers because it gets closer and closer to 0. So we know that the sum has to stop somewhere, and it stops at 808. So yeah, that's all for day 4 question of the day.